In this video, we are seeing the 8th chapter in Cbse Class 9 Science textbook, that is motion. We've already seen two parts, two videos regarding this chapter. So now we'll get into the third part of the chapter. So the first two parts we discussed till velocity. Okay, we discussed what is distance and displacement, what is speed and what is velocity. Under speed we also discussed about average speed. So I told you we'll be discussing about average velocity in the next video, but before that we need to learn a couple of topics. So that is what we'll be discussing here. Okay. The velocity, what we learned already, we'll just give a quick recap. So velocity is nothing but speed with direction. Okay, when you have a direction, and also that is the numerical value. We already saw what is a scalar quantity and what is a vector quantity. So what did we see in that? Scalar quantity has only magnitude, or you can call it as numerical value. Numerical value. A vector quantity will have both magnitude and direction. So it will have both magnitude and direction. This is what we saw about these scalar and vector quantities, and we learned that velocity is a vector quantity. Velocity is a vector quantity. So what is velocity? Speed of an object moving in a definite direction. So this velocity can be uniform or it can be variable. So how can we change it? By changing the numerical value, that is the object speed, or the direction, or both. That means either of one can also change. Just by changing the direction also it can change. Okay, and it is a vector quantity and the unit is the same as speed, that is meter per second. So this is the concept which I wanted to teach you before we get into the concept of average velocity. So uniform and non-uniform motion. So what is uniform motion? So here you are able to see these two cars. Okay, so these two cars, you can see they are moving with uniform motion, that is they are moving with the same speed, you can say, or you can say it travels equal distances in equal intervals of time. It travels equal distances in equal intervals of time. So that means what? If the distance is increasing by 10 kilometer, okay, then the velocity will also, like if it is increasing by 10 kilometer, the velocity will also increase, the time will also increase uniformly. That means you can say if it was traveling at 10 kilometer in 1 hour, 10 kilometer in 1 hour, it means that in the second hour again it will travel what? 10 kilometer only. But this is not practically possible. Can we travel in uniform motion practically? That too in our traffic, in our city traffic, it's highly impossible. So first what you will do, you will be traveling slow or you might be traveling fast. So it will keep on changing. Okay, so this is uniform motion. Okay, but a body, so it is traveling with the constant speed. There we saw, right, in the previous thing. Here we saw it can be uniform or variable. So when it is uniform, you call it to be uniform motion. So what is uniform motion? A body traveling equal distances in equal intervals of time. This is not new to you. You would have already learnt it in your lower classes. The body is said to be moving with constant speed. Next is non-uniform motion. So you can see this small object, can see this object is continuously moving but not in a constant speed. Suddenly it is moving slow, suddenly it's moving fast. Okay, so that means it is traveling unequal distances in equal intervals of time. Remember, you should not write unequal here. Unequal distances in equal intervals of time. That means for the first 1 hour, if it is going to travel 10 kilometer, the second hour it might travel 5 kilometer, or it might travel 15 kilometer, or it might change. Okay, again the third hour it might travel again 10 kilometer. So it is going to the timing is going to be the same. So that's what you are saying, equal intervals of time, but the distance is unequal. This distance is going to be unequal. So here you are going to say that the object is going to move with a changing speed, or you can say it is going to be variable. Okay, variable speed, changing speed, and then it is said to be in non-uniform motion. It is said to be in non-uniform motion. So this is everything about your uniform and non-uniform motion. Now we just have those two definitions here. What is uniform motion? When an object travels equal distances in equal intervals of time. Okay, so here you can say that in the example which we saw first, we could see that both the cars were traveling equal distances in equal intervals of time. Okay, then for this unequal distance, we saw that small object which kept on moving with random speed. Okay, so this is about uniform and non-uniform motion. Now we will learn about average velocity. Why did I teach about uniform and non-uniform motion before getting into this? Is because you have average velocity changing for uniform and non-uniform motion. For uniform motion, the average velocity is given by the arithmetic mean of the initial and final velocity. Arithmetic mean means what? It is nothing but the average. Average means what? You are going to write the sum of the values divided by the number of terms. Okay, so here sum of what? Sum of u and v. How many terms are there now? 2. Okay, so it is going to be what? U plus v by 2. That is what we have here. Okay, so your average velocity is nothing but the sum of the initial and the final velocity for a given period of time. So this is for your uniform motion. Why? Because for a uniform motion it will remain the same. How much ever time you take, it is going to remain the same. The velocity has not changed. So that is why we have this formula. Next we will see about non-uniform motion. So when you have non-uniform motion, you yourself know it is continuously going to change. So you will automatically take the regular formula for velocity, that is your displacement. When you learned the formula for average speed, so what did you learn? Average speed is equal to total distance by total time taken. Total distance divided by total time taken. Here we are learning this for average velocity. So instead of distance, you are replacing it by displacement. You are replacing it by displacement. That is what we are seeing here. So here we are seeing about the displacement. Displacement means what? The shortest distance between the initial and the final point. So the displacement by the total time taken, because average velocity for non-uniform motion, it means that the velocity is going to continuously keep changing. Okay, so that is what happens even in speed. Okay, for now speed you cannot say it is uniform. That is why we are having the formula to be similar. So in case you forget what is for uniform and non-uniform, remember for uniform it will be the same velocity, so you are going to add the initial and the final velocity by 2 for uniform motion. For non-uniform motion, it is similar to your average speed. So in this way, if you remember, you will never forget the formula, children. Next, we are going to learn about two other definitions, odometer and speedometer. You would have seen this in all your vehicles. It might be either digital or analog. Okay, here you have an analog come digital. Okay, so this one gives you the kilometer, that is the distance it has traveled. Okay, this one gives the distance it has traveled. Okay, whereas this one is going to talk about the speed. Okay, it's going to talk about the speed. That's what you can see here, kilometer per hour. Okay, this is your kilometer per hour. So this one, the one which is going to be here outside, that is called the speedometer, and this is called the odometer. This is called the odometer. So odometer will measure the distance traveled, that is what is given in terms of kilometer here. Okay, and the speedometer measures the speed of the object, or you can say the speed at that instant. Speed at that instant. So this speed is called the instantaneous speed. This is called the instantaneous speed. So you would have come across this word sometimes in some numericals. It is nothing but speed at that particular instant will be called as instantaneous speed, and odometer measures the distance traveled by the object. Now we will see a numerical related to the concept which we have learnt. Okay, so let's look into the sum. Okay, a body travels 4 kilometer towards north. Okay, let me draw here 4 kilometer towards north. We all know north, south, east and west. Okay, 4 kilometer towards north, and then turns into his right. So he is facing this way. So what will be his right? This side will be his right. Towards his right he is going to turn and is going to travel another 4 kilometer. 4 kilometer towards north, 4 kilometer towards the right before coming to rest. So that means what? Here he has stopped. Here he has stopped. Okay, so this I can say it is going to be his initial position, and this is going to be his final position. Okay, calculate the total distance traveled. You know what is the distance? Distance means what? Total length of the path. Okay, or you can say the path length. Total length of the path. And next they are asking about the displacement. Displacement is what? The shortest distance. Shortest distance between initial and final point. Okay, so here what is the length of the path? Length of the path is what? Towards the north and then towards the right after reaching. So 4 plus 4. So that is what we are seeing here. See, this picture is drawn here. Look at this picture. So from here he is traveling towards north, and then he is going this way and towards his right, and he is traveling here another 4 kilometer. So distance traveled is what? Here according to this diagram it is OA plus AB. So it is 4 kilometer plus 4 kilometer, which is going to be 8 kilometer. What is the displacement? Here the displacement is what? The shortest distance between initial and final point. So what is the shortest distance? This is the shortest distance. So now can I say I have a right angle triangle? Yes. So see, I am just redrawing the right angle triangle here. Okay, I have a right angle triangle here. I am just naming it to be A, O and B. So this is going to be 4 kilometer. This is going to be 4 kilometer. This is what we need to find out the shortest distance. That is your displacement. So as per the Pythagoras theorem, you know that your square of the hypotenuse is equal to the sum of the squares of the other two sides. So you can say that OB square is equal to OA square plus AB square. So OB is equal to square root of OA square plus OA square plus AB square. Okay, that's what is here. So it is AB, OA square plus AB square. So you have 4 square plus 4 square, square root of 16 plus 16, square root of 32. You can find out this value of the square root by using the long division method, which you would have learnt in your lower classes. Okay, so and you will get the value to be 5.65 kilometer. See, the distance was 8 kilometer, but the displacement is always lesser. Remember, the displacement is always either equal to or lesser than the distance. It can never be greater than the distance traveled by the object. Okay, so with this we will complete this video. We will get into little more numericals. Before that, we will learn about another small concept in the next part of the video. So thank you, children.